Hello, everyone, and welcome. My name is Scott Sorrell. I work for a company called Balchem Corporation. If you don't know who Balchem is, I'll just take a few moments to kind of give you a brief overview. Balchem's basically a nutrition company, both in human nutrition and in animal nutrition. In human nutrition, you'll know us for things like we put the pop in your Poppin' Fresh, we put the rise in your self-rising dough, and we put the sour in your Sour Kids candies. So those are just kind of a few things that we do. On the animal nutrition side, we manufacture a line of microencapsulated nutrients, rumen-protected nutrients, and chelated minerals. Most popular product that we have is called Reassure. Our tagline at Balchem is real people, real science, real results. Real people, we like to see ourselves as being honest, transparent, capable, approachable. Real science, science is woven into our very DNA. Science involves everything that we do. We've got some of the most researched products in the industry. And real results, that's really what it's all about, right? Bringing results to you and your dairy farmers and your dairy cattle. So that's who we strive to be every day. With that, your next speaker is Dr. Barry Bradford, presenting How Do We Get the Next 5 Pounds of Milk? Dr. Bradford is the Clinton E. Meadows Endowed Chair in Dairy Management and Nutrition at Michigan State University. Through his research, Bradford aims to better understand the metabolic physiology of dairy cattle to identify strategies that will improve the economic and environmental sustainability of dairy production. Prior to joining Michigan State, Bradford spent 13 years at Kansas State University as a professor in animal sciences and industry. He earned his bachelor's degree from Iowa State University before earning his PhD at Michigan State. Dr. Bradford, the floor is now yours.
Thanks, Scott. Take that. Well, I appreciate the chance to be here. I was talking with Mike Brook yesterday. I think I'm like 2 for 5 in actually making it and being able to stay in Reno for this whole conference. So I know I'm not the only one that's struggled to be here at different times, but I'm glad you guys are all here. So leading into this, I think the reason to give this pitch is we've had interesting discussions with some of the legends, as Scott said, in the industry, and that, you know, they talk about early in their careers, people would talk about cows making 80 pounds of milk, and can we even go higher, and that sort of thing. And right, we keep keep getting these animals to perform better and better, and there doesn't seem to be an end in sight. And I think that's the reality of the economics of operating a farm in the profitability range, right, is you've got to keep pushing for the next level, of course, without sacrificing health, and that's some of what I'm going to talk about. So I've mostly talked to nutritionists, so this is geared a little bit to nutrition, okay, and so I'm sort of ignoring genetic pieces. Of course, those are all parts of how we get more milk. But for nutritionists and people managing nutrition programs, how do we do this? And I think traditionally we've mostly focused on this. So we need to better refine, especially as genetics advance, how does the modern dairy cow, what are her requirements? You know, do we need more histidine? Should we be looking at potential requirements for polyunsaturated fatty acids? All these things, and they have to be constantly reconsidered in light of new biology and new understandings, and that's nothing we should turn our back on. I think that's been an exceptionally fruitful way to move forward in nutrition of cattle, and I'm not discarding that at all. But it's easy to get caught in this being the only way that we can push milk forward. So I wanted to throw out some different ways of thinking about this. Another way that we could potentially get higher average milk out of a herd, of course, is to decrease the number of animals that are hit by negative health events. So if you just look at the data that's out there published, somewhere between 20 and 40% of our cows deal with meaningful subclinical or even clinical problems in the transition period. And I'll show you some data to back this up, but let's say for the sake of argument that most of those cows were actually making 5 pounds less milk for much of their lactation because of that short-term insult. And okay, that's not 5 pounds for the whole herd, but that's a meaningful impact, right? So let me back that up just a little bit. This is a collection of data from a bunch of observational studies, all cited here at the bottom, where people went to commercial herds. They tracked cows that had some kind of problem in the first week or two post-calving, ones that they survived, okay? So they're cows that stayed in the herd, but then they compared them to herd mates, same pens that didn't have those problems, and just projected how much milk did those cows that had that problem give up because of that issue. And so these are all problems that these cows, again, recovered from, but early lactation mastitis, metritis and ketosis basically knocked those cows back over the whole lactation anywhere from 750 to 1,100 pounds. And again, obviously that's not happening in the 3 or 4 days that you're actively dealing with the infection or the ketosis. It's because for whatever biological reasons, she's not able to hit the peak milk that we're expecting, and then we have that, just not achieving what she could have achieved for the whole rest of that 300-day lactation, right? So these are often hidden costs because these cows are just not doing awesome. Unless you're really spending a lot of time digging through cow histories, and that's even if you enter this stuff in your herd management software properly, you're not going to pick up that these things tie back to her transition problems, okay? This can get touchy, right? But another thing we could think about at least is, can we actually turn down our culling rates or our turnover rates a little bit to increase average productive life and perhaps decrease the fraction of first lactation cows in the herd? And I know Mike's going to talk about this tomorrow, and there is nuance here, okay? But I want to at least enter this into the consideration. So one thing that comes into play here is transition cows, not only, if they deal with these problems, they not only have less milk over the whole lactation, but if you follow those cows, their risk of leaving the herd before the next calving is actually a lot greater. And again, this may not be mechanistically tied. A cow that had mastitis here may end up leaving the herd because she got DNB'd and she gets sold at 400 days in milk when you dry her off. Why was she not pregnant after the 4 breedings you gave her? Well, often, it's tied back to setting her up wrong physiologically because of the disease she was dealing with. So cows with mastitis had 3-fold greater risk of leaving the herd after that. Metritis, it was 1.5, and ketosis was 3.5. Okay, so again, a lot of these, it happens months later. You don't necessarily tie it back, but these transition problems have big costs. Okay. It was actually kind of hard to find published data on this. Mike, maybe you can help me on that. But I did find this paper that shows basically over 1,300 lactations what the average milk yield for a 305-day standardized lactation. This is in kilos. But you can see everybody knows that first lacs don't give as much milk as seconds. But there's still a rise even from third to fourth. It's not as dramatic. But so we sometimes, if we're averaging 2.2 lactations in our herds, there's a fair bit of milk we're giving up potentially, right, by not having a higher proportion of our cows be in third and fourth lactation or on. And so Albert DeVries has done some really nice analysis on this, and it's a very complicated question if you ask, what is the most profitable average number of lactations in your herd? And he's done, I think, a pretty good job of at least making an attempt at putting those things together. So what's the opportunity cost of the value of a calf that you're going to sell? What's the cost of an aged cow? So cows that are sold culled out here are not going to bring as much value as cows here. I need to go back and look and make sure that he accounted for the greater risk of death if you hold a cow that gets older, right? That's a real thing to factor in. Lack of maturity cost, that's accounting for the fact that these younger cows don't make as much milk, okay? So that green bar showing that we could get more milk if we have older cows. We have greater herd replacement costs if we're turning the herd more quickly, right? So that's a big chunk in here. And then the other thing, the kind of the flip side of that is the genetic opportunity cost. So a lot of people like turning the herd a little quicker because you can make more genetic advancement more quickly, right? And so that does show up here as well. And his net analysis here, and I think he's still working on refining this, but his take home in this paper was that basically the optimal profitability in this model was somewhere between averaging 4 to 6 lactations in your herd, which is a long ways from where we are on average in the U.S., right? And so if you say the average herd now is like 2.3-ish, his analysis would say we're giving up at least $100 per cow per year in opportunity. It is hard to come up with a right answer for this, right? So optimally, you would do this fancy math for every single herd, right? And Mike's going to talk about that some tomorrow. The point is mostly that this is something we should think about if we want to get more milk out of our herds. We don't spend a lot of time thinking about average age of our cows in our herds as a factor in that. Regardless, I don't know anybody who likes to have cows getting sick and culling them for that reason, right? Nobody's going to argue that. If we need to cull cows, we want to get a lot of value. They need to be healthy, right? So anyway, so the question is, how do we keep our herds healthier? Because it does help drive productivity. And as a nutritionist, this is a big focus of my research and the work of my group, is these fancier ways that nutrients can work beyond just saying, okay, we require this many grams of methionine per day for a highly productive cow. Now we have these sort of functional attributes or the bioactive aspects of how nutrients can work. And Caroline should take a bow for drawing this because I could never have done this myself. So, okay, so one of the things that we've dug into is some of how nutrients can actually influence immunity. And there's lots of ways that can work, but one of the ways is potentially directly impacting immune cells. Okay, and one nice thing about a question like that is not most of what we want to understand in biology, you can't really put in a test tube, okay? And anything we do like that, I have a lot of caveats. It's not the same as a cow, okay? But if we want to know specifically how a nutrient can affect one immune cell, it's actually not a bad idea to sort of take that out of the cow and play with what you put the cocktail you put that cell in and see how it responds. So we did an experiment like that we published a few years ago where we isolated different types of immune cells from blood of lactating cows. And the take-home was, as we put increasing amounts of choline within the physiological range, the cells that are mostly responsible for an inflammatory response, when we expose them to endotoxin, had a calmer response, I guess. Okay, and you could argue if that's good or bad, but there was a less inflammatory response to endotoxin. On the flip side, the cells that are more responsible for immune memory, lymphocytes, actually had a greater response when we stimulated them if there was more choline there. So we thought this was kind of interesting, maybe some hints of a little shift in immune focus, if you will, in which arm of the system is doing more of responding if there's more choline. And then you layer that on top of this classic data showing that total choline metabolites in plasma really changed quite dramatically from early lactation to mid-lactation. Sorry, that's late lactation. But anyway, some good evidence that maybe there's some reason to think these cows could respond to feeding more choline and getting more choline metabolites in the system. And this is actually a measure that's relevant for a circulating immune cell, that if they're affected by the choline around them, the blood plasma is what's around them. And so this is kind of, I think, relevant data. So that led us to this question. Okay, there's a good meta-analysis that was published, I think, last year on choline that says, on average, cows make about 2.5 pounds more milk if they're fed choline in the transition period. And there's a number of mechanisms that could underlie that, but I don't think it's really worked out exactly why it has that effect. So we asked, maybe choline actually works mostly through making animals more resilient to the challenges, because a lot of transition cows have some kind of either immune challenge or some inflammatory scenario that we think we have good evidence that decreases productivity. So maybe choline is actually working sort of through those mechanisms. So this is Turner Schwartz's work. He actually just started last week on faculty at South Dakota State, so I'm excited to see what he does there. But this is part of his postdoc with us. And we basically put 60 cows randomized to get 45 grams per day of a rumen-protected choline product from Balchem. It was a prototype. It's slightly different than the current Reassure product. And then we also tested 30 grams per day, which delivers about the same amount of choline that the current Reassure label would deliver. So currently, most people feed 60 grams per day. This is delivering the same amount of actual choline ion. Okay, so that's kind of the default amount. And then, of course, we had a negative control. And other than, compared to other transition experiments, the only thing that was really different here is that we wanted to add an additional challenge on top of the transition period. So we wanted to say, if these cows really go through something like a mastitis event, does choline make them more resilient? Does it hit milk production less in that scenario? So we put them on treatments starting 24 days pre-calving, followed them closely through 21 days post-calving, but on day 17 post, they got LPS challenged on both rear quarters. So I'll talk you through that in a minute. The first, and this wasn't really a core focus of this study, and we didn't necessarily anticipate this would be a big part of the story, but our first observation that was pretty surprising is a dramatic increase in colostrum yield with choline. So didn't matter the dose. we saw basically an 80% increase in colostrum yield compared to the negative controls in this group, which was significant. And protein yield followed that. Fat yield was sort of more borderline, so the choline 30 was the only one that was significantly different. But the important take-home is IgG content by refractometry was not different across treatments, so total IgG supply was greater as well. Okay, so pretty interesting result. And this is drawn a lot of interest in Michigan, where we definitely have huge seasonal challenges with colostrum in the fall. And we've been working with some people to at least try if this will help with that. Secondly, of course, one obviously major outcome is just milk yield. And so we saw a very clear separation of treatments here. Again, really no evidence of any dose effect. So the red is going to be choline 45 throughout here. The blue is going to be choline 30. And the black is control. And we'll get into the LPS treatments later, but I'm just showing you the overall effects before challenge first. So this is again, kilos on the y-axis. So this is actually about a 9 pound per day response, which is substantially greater than most of the studies have seen. And why that is, I can't tell you. Multiparous cows, and again, about 20 cows per treatment here. None of that was through dry matter intake, so we just saw absolutely nothing in dry matter intake, basically equal across the board here. So if you're not used to hearing about endotoxin challenges or LPS challenges, let me walk you through that for a second. Everybody's familiar with gram-negative E. coli mastitis, a fairly common form of mastitis. So you can infuse E. coli and actually cause mastitis, but the problem is you're going to have a lot of variation across animals, and some animals are going to kill the bacteria right away. Others, it's going to grow and fester for weeks unless you treat it. So you end up with just a huge hodgepodge of biological responses. So one way we kind of constrain that variability is we just extract, well, we don't do it, okay, a chemical company extracts this endotoxin, lipopolysaccharide, which is part of the cell wall of the E. coli, and we purify that, and that's really what our immune system is looking for when it's sensing, looking for a gram-negative infection. That's one of the main ways that your body senses that. So then basically we can put that in a syringe and inject that up the teat canal, and we're basically tricking the immune system. It sees this sign and it thinks, oh, there's E. coli here, which there's really not, but it's going to have all the same initial responses it would to an E. coli infection. Okay, so it's a way, without having a true infection going, we can see how she responds. So I won't go through all the details we collected, but I mean, one of the main things, of course, we'd expect to see, if she thinks she's infected, she wants to bring immune cells to fight the battle, right? So this is mostly going to be neutrophils coming out of blood. We call it extravasion. It's leaving the bloodstream, coming into the mammary gland, trying to engulf bacteria that aren't really there, but she thinks they are, okay? So we see a massive swing here. In 8 hours, we go from a somatic cell score of 2 to 12. Okay, and no real obvious treatment effects. There's some time differences here, but we didn't see really anything to write home about in terms of differences by choline here. Going with that, we were actually surprised exactly how high this got. So you would again expect a fever in this case, and these cows peaked at 106 degrees Fahrenheit. And the reason we were able to capture that is we had a indwelling thermometer in a cedar in these cows, so we have constant body temperature monitoring. They got very hot, but then they recover extremely quickly. So by 16 to 20 hours post-challenge, they're kind of back to baseline. One thing we did observe here, which I'm not sure what to make of, I have really no idea what's going on, but the choline 45 cows had a higher baseline after they came back down. So if somebody can explain that to me afterwards, but that's kind of interesting. Otherwise, no obvious treatment effects there. We also did a whole bunch of blood analyses to try to see what's going on metabolically. So this is a really interesting part of science now, understanding how nutrients are used by the immune system and how the immune system alters use of nutrients by the rest of the body. One thing that Leaky Lance, I just learned that today from Brady, wherever you are. I don't know why I never heard that before, but Brady and Lance and others in that group talk a lot about the rapid use of, there you are, rapid use of glucose by the immune system, which is absolutely part of the story. I haven't seen a lot of data like this, but this is kind of the backside of that. Those immune cells cranking through glucose, they spit out lactic acid, lactate, just like if you run too fast for your lungs, right? You make lactic acid. And so we can really see that response here. clearly having immune activation. They're burning through glucose, so they're releasing lactate. And this is about a 4-fold jump in lactic acid in the 8 hours post-challenge in those cows before it comes back by about 48 hours. So again, kind of the same story there. And actually, we saw slightly less, lower concentrations of lactic acid with the choline-treated animals, which maybe means there's less of that activation of innate immune cells, but we're a little hesitant on that because they actually were lower before challenge too, so we're not quite sure exactly what to make of that. Another thing just kind of interesting with these challenges, and we'd expect this with a cow with gram-negative mastitis, we see massive drops in circulating amino acids. Now again, they recover very quickly, so by 24 hours she's kind of back to normal, but circulating methionine drops by 70%, in 8 hours after this challenge before coming back, which is, that's a shocking magnitude. But a lot of things are changing very dramatically in these challenges, okay? So big picture, though, from a production standpoint, whole animal physiology, how did she respond if she had choline on board? Well, we didn't really see a difference in dry matter intake. So we would expect if we give inflammatory challenge that she's going to drop in intake, and in fact, that's what we see, about a 35% drop in dry matter intake, and then they sort of slowly recover over the next 4 days. But no evidence of a treatment effect or interaction there. Milk yield response, again, about the same story. So highly significant effect of LPS, of course, more like a 40% drop. It recovers pretty quickly most of the way, okay, and then sort of slowly creeps up after that. But again, no evidence that choline minimized the hit, I guess, if you will, okay? So choline still had its overall effect. It just didn't interact with LPS. Some of these are just kind of interesting things to play with. We did in our model, as on the research community, we're talking a lot about how do we use all the genetic tools we have now to give more insight into the biology underlying even nutrition research. And so we've been doing some stuff where we use in our statistics some of the genetic factors that we have for those cows. So this is the predicted transmitting ability for somatic cell score on the x-axis. And then the y-axis is the somatic cell score at the peak after the challenge. So this is challenge, that's why it's such a high number. Okay, so the black line is control cows. So if we didn't give any choline, as you'd expect, the cows with genetics for more somatic cells had a greater, more dramatic response to endotoxin. I don't know if you'd expect that or not, but it's kind of interesting. They are more responsive to a challenge. So if you put it on a normal scale, cows with low somatic cell score genetics ended up with just under 5 million somatic cells per mil, whereas the genetically high somatic cell cows had almost twice as much in response to LPS. So that's kind of interesting. But the other thing is, statistically, the treatment interacted with the genetics. So these cows that were genetically wired to be really responsive and crank up somatic cells when they were challenged, actually, that was dampened by feeding choline. So that's reducing it by about 2 million, about a 33% reduction in somatic cell response to endotoxin in those genetically wired cows. So I don't know exactly what to make of that, but that's kind of interesting. To me, this is maybe one of the most important take-homes from this study. So one of my big things that I soapbox on is for transition cows is don't focus on the cost per cow per day of any strategy in transition cows. And that doesn't mean I think you should feed every foo-foo dust under the sun, but I think you should do the ROI math on what's it costing you per lactation and what are the potential benefits for the whole lactation. Because a lot of the benefit is how is this impacting a cow's ability to hit a good peak and succeed from there on. And this is a really nice example of that. So we tracked these cows after we stopped feeding choline for another 8 weeks. And you can see treatment remained highly significant throughout this window of time. And in fact, the magnitude of the treatment effect didn't decline. In fact, it was slightly greater across those 6 treatment groups. The choline effect was slightly greater in this carryover period than the treatment period. So about a 10 pound per day. And again, if you look at all the studies, that's bigger than you'd expect on average, okay? So I'm not sure why, but we did see a really nice response. But the other thing I like to point out here, the endotoxin challenge remained highly significant through this whole window of time. And in fact, even by the end of this time that we were tracking cows carefully, they still were making 5 pounds per day less milk than cows that were not challenged. Okay? Please nobody tell our herd manager back at MSU that, because I didn't actually budget to pay for that loss of milk from the LPS. No, I'm just joking. But that's a big effect, right, for a long period of time. And yes, it was a dramatic challenge, but most of the blood markers, most of the body temperature, all that was back to normal within 24 hours. It was a sterile infection. There was no live bacteria there. It's, for a dramatic mastitis event, it's like the best case scenario, and yet we're still seeing months later a 5 pound per day hit. Okay, again, to my point, how can we get more milk out of our herd? Part of it is preventing these kind of events, right? One last kind of interesting interaction, another genetic thing here. So PTA for milk. If you look across this range on the x-axis, cows slightly in the negative to about plus 700. And we saw an interaction here as well. So cows on the more elite end in terms of milk production genetics, we didn't see clear effects of choline there. But on this end, we saw really dramatic effects. So I guess the lowest genetic predicted cows for milk yield, we're looking at something like a 20-25 pound response. Now, for this kind of analysis, this is a very small set. Geneticists would want to do this in 10,000 cows. So take that with a grain of salt. It's 60 cows, but still kind of interesting. So lastly, I'll touch on the calves. So just to be super clear, I didn't say this before. We fed the calves commercial colostrum. We made the decision going into the study. We didn't want to study the calves with the additional wrinkle of having colostrum from their dams. For one, we wanted to test for IgG content and not feed some calves poor colostrum and such. So anyway, this is only looking at in utero effects of choline, okay, when I give you reports on how the calves responded. And this is actually published. Some of the rest of this we don't have out yet, but this was published last year. So just a couple of highlights because I'm going to run out of time. One thing that was interesting, we look at an oxidative stress index, okay, so if you're familiar with the concept of oxidative balance or oxidative stress, we can look at pro-oxidants, things in blood that are reactive oxygen species that are kind of signs of things going haywire chemically. And then we can look at antioxidants. So we're all familiar with those, like, we're all familiar, but my brain isn't working. Like vitamin E is a great example of an antioxidant. So you look at total antioxidant capacity, you basically challenge the blood and see how much it can handle before it loses the oxidative balance. So we used an index of the ratio of those two, and this did show that the choline 30, well, the calves from choline 30 dams actually had a lower oxidative stress index, meaning they had further from the line of having oxidative stress, so better oxidative balance, if you want to say it that way. Okay, the 45 dose, for some reason, we didn't see an effect in that group. We also saw here an interaction by calf sex. So in the bulls, we didn't see any evidence of responses in this inflammation marker, haptoglobin, but in the heifers, those from dams getting the higher dose, the 45 gram per day dose, showed a decrease in haptoglobin in the early days post-birth. That being said, we did see, I guess, statistically an overall effect showing slightly greater average daily gain for calves from the choline 45 dams in the first week. But that's basically, they were just converging to the mean here, so they were slightly lighter at birth. And I hesitate to conclude that's a true treatment effect. So our takeaway here, no real obvious effects on growth, but again, you wouldn't design a study for calf growth with 60 animals, right? So it's not super powerful for this. So anyway, we didn't see much that I would take away from that. So highlights from this study. For one, that 80% increase in colostrum yield I think was really surprising to us, and I think worth exploring further. And if there's farms you work with, I think it's something to consider if they deal with seasonal colostrum problems. Again, that response of 10 pounds per day in early lactation milk yield all the way through 84 days in milk, greater than we typically see across studies, but highly significant here. But our core question, does it look like choline is having its effect by making animals more resilient to these hits? That doesn't really fit with the data here. It doesn't look like it's explaining the milk response here because we saw it beforehand and the choline didn't diminish the negative effects of LPS in this study. I think the gender interactions are interesting, and I think we have a long ways to go to fully understand those, but it's worth thinking about some of those things. And again, just to make this point, I don't know that anybody's shown in a controlled study before that if you give LPS early lactation that you'd hit peak milk yield and affect milk yield for at least 2 months by that magnitude. Okay, so that's a big deal. And then some hints of improved oxidative balance and perhaps inflammatory biology in the calves, but probably not a big enough study to really assess if that makes them healthier and more productive down the road from there. So again, how do we get the next 5 pounds of milk? Of course, we want to make sure we're hitting nutrient requirements, and maybe that's how choline's working here. Okay, just simply put, that doesn't necessarily explain the biology, but that's probably the best way to think about it. But again, I'd turn us back to there are nutritional ways we can try to make animals healthier, to not have these hits that affect cows for months on end, and also hopefully to keep them in the herd longer so we can hit some of those fourth lactation cows making just tons of milk. Okay? And with that, if we have any time, I'd be happy to answer any questions. Thank you.